All right, young scholars, just like last week, we are going to be focusing on databases. If you download this PowerPoint, you'll notice the PowerPoint I'll touch on momentarily. Additionally, you have this additional link here. This is a YouTube video shuffle of, I believe it's 15 lecture videos I taught of a 400 level database course at Rowan University a number of years ago. You're more than welcome to listen to them as you so choose. You don't necessarily need to unless you feel like it. The content may be more advanced than the needs of this course, so that's perfectly fine if you choose not to. We'll touch on database assignment and the website plan rough draft at the conclusion of the presentation. So this week we will focus on database data storage, how individuals decide databases are set up, and computations associated with databases. So some fields within a contract or contact record may be empty if that's allowed. So see here we have Joe Smith does not provide a home phone. Mary Jones does not provide a work phone. So to potentially avoid empty cells or fields, you can have selections. So in this instance, we allow the user to select a phone type, cell, home, or work, and put in the phone number they feel like choosing. So this could result in the creation of multiple tables to allow us to store information. It may make different queries or selections easier or harder to find information. So in this table in slide 3, if I were to try and search for Mary Jones contact information, I have all of it in one spot based on my query. Based on the table set up in slide 4, if I search for Mary Jones's info, I don't necessarily have it unless I search by the ID and pull the information that I need. So entity relationship models are how we set up or design our specific databases, how we're going to create it in real time. So in this example, we have the depositor. The depositor has information of the customer and the account. So the depositor could be you. You could be the customer, your name, your social, your street address, your city address. You also have an account associated with you, which will have an account number, a balance, could have a PIN number as your specific sections within. So here we have a listing of database languages, data definitions languages, and data manipulation language. A database administrator has specific tasks that they may need to accomplish. Schema definition, basically your database definition. That is where our entity relationship model comes into play. You have to consider storage structure, physical organization, who can have access, and specific integrity required as a database administrator. So there are commonly two types of database users: the programmers, who's creating it, and the sophisticated users, who's using it to find the information they need or querying the database to get that information. Next, we have query processor components, the DML compiler, the embedded DML precompiler, the DDL interpreter, the query evaluation. Then we have storage manager, takes over authorization integrity, transaction, file, buffer, etc. A physical system, as we talked about last week, deals with files, indices, metadata, etc. And here's the level of where everyone goes. So a database management system may deal with everything. A user may just deal with applications that utilize all of this information. So this is in essence a visual representation of who accesses and focuses on what. So within our entity relationship diagram, the rectangles represent entity sets, the ellipses represent attributes or fields, the diamonds represent relationship sets. You saw the diamond we had earlier. They can access all of the rectangles. Lines, double ellipses, dashed ellipse, double lines, etc. So here we again have that example. The diamond can access the rectangles and everything within the rectangles. So in this instance, we have two tables, customer and account. They have no relationship. Account number, account balance, account. Customer, customer name, social security, customer street, customer city. Only the depositor can access both of those. When you see 1-N, that means it is a one-to-many relationship. So in this case, one customer may have many accounts. So think of it, you have a Instagram account, a Facebook account, a Snapchat account, etc. On slide 17 here now, we have customer M-N account. Now the M-N means many to many. So we can have many customers having many accounts. Here we have another visual representation of the different pieces of ER diagrams as explained on slide 13. On slide 19, we have a sample extensive ER diagram. We have a branch city, a branch name, branch, local branch, going through all these different sections broken out of the depositor. The depositor can access almost every piece of our different entity. And this is how individuals decide on building their databases. So what tables do we need? What fields do we need within each table, etc. So next we focus on functional dependencies, which basically means you depend on another field. So in this instance, no one cares about student ID unless you have the student name. What good is the course, just knowing the course, if you don't know the teacher and the textbook? So here we have inference rules. Basically tells us what focuses on what. What do we need to function? Well, X needs Y, XZ needs YZ, etc. On slides 22 through 25, you have proof of these different types of dependencies. You'll notice on these slides that the term tuple may be referenced. A tuple is simply a more professional term used for a field within a database. So joining two fields together that may easily be broken back apart, in this example, student name, student ID, we can break down our tables even further. You'll notice that name is in all tables, which may result in, as you see on slide 28, repetitive data. So we have Muhammad, two separate listings of the two classes that he is taking. So by using that lossless join property, we're able to limit any specific repetitive data that we don't need. You'll notice here on slides 30 through 32 that we list tests for lossless join property. It's simply beyond the scope of our course, so we're just going to leave it there for you guys to read. On slide 33 here, we have the Boyce-Codd normal form, which is another type of relationship associated with functional dependency. So I wanted to show you here on my specific website, innovativeprof.com, that when I click into my site and MySQL, that I have a great deal of databases here listed. These are all databases for the website itself using WordPress, as well as the blogs for each of the universities I've taught at. So you'll notice here that the blogs have limited size requirements. They basically just have the WordPress installation and maybe 3, 4, 5 pages associated with them. Whereas the actual website itself, run off WordPress, is 5 times the size because of the different web pages, files that are all stored within that WordPress download. So your assignment for this week associated with databases is that you're going to use the ER model, as we've described, to draw how your website would look as a database. Your home page would be a diamond. Your pages linked to the home page would be your rectangles, and any subpages with those pages would be circles. So home page, associated page, subpage. So let's say you have a page about your social media. You could have, a drop down, a link to your LinkedIn, your Facebook, your Instagram, whatever it may be. Those would all be listed as subpages. This is to also help you with your website plan rough draft. You're going to create a plan for a personal or professional website. Your plan should include a description of the different pages you might have. For example, you might have a home page, an about page, a work experience page, course artifacts, etc. Each page should have a little small plan as to what you're going to put on it. So it's much more basic than the proposal you did in Info 2105. That's because in Info 2105, that was geared more towards, hey, if I ever do a website for somebody, this is what I'm going to have to do in order to entice them to actually pay. Whereas this is for you personally. Okay, I'm going to do this homepage, and I write 2 sentences about what's going to be on it, and you do that for each of those pages. So the database assignment helps you square that away and organize what you're going to do. Okay, everything's linked off the homepage. I'm going to have these 8 pages, and only 2 of those pages have drop downs that require subpages.